hire somebody to take this. How many of you guys, let me ask you, how many of you have actually bought this by now? Because I do want to get to the point, this is why I didn't really do this today, I want to get to the point where I can trust just saying, okay, do page 4, do the problems, and everybody's able to do that. If you haven't bought this yet, you can't. This is about $5.
They're running out at the bookstore?
They're running out?
Yeah, I only saw like 3 left.
Wow.
Yeah, I think they have some more next week or something like that.
That sucks a lot. They're supposed to have enough for all of us. Okay. Well, I can keep making up problems of my own. That'll work too. Oh, thank you. Let me take a step back.
Oh, yeah, they're coming.
Thank you. If I have a problem like this, let's do this one together. Okay. So I kind of appreciate the fact that I heard a few people, I think somebody just said geez, and somebody else went, I like that. Because I understand, there's a lot of crap going on up there. But here's something I hope you'll take to heart. The people that do really well with math are the people that naturally break a problem like this down into its parts. If you don't naturally do that, or don't naturally have it come to you to do that, math is going to be more difficult. So when I look at this problem, I don't look at the whole damn thing, because that's going to just drive me crazy. What I see is, oh, that's a distribution problem. That's easy. Well, there's another distribution problem. That's easy, relatively easy, right? I don't think about all the stuff I'm going to have to do. I only think about the stuff I got to do right now. So it doesn't all get in my head and go, holy shit, I got to be able to do this whole thing. No, I don't. I only have to do this right now, right? So, and the other side of that, obviously we have to know that distribution is what we look for first. And it seems to me from what you guys have done, it does sort of come naturally to you by now. That's what you look for. You look for these distribution parts so that you make them free. You make them so you can move them around. So what do I get when I do this here? I like it. Negative, negative is plus. So that's still there, right?
Yes.
How are we doing? So 3x, what happens here?
14.
Minus 14.
Minus 10x.
Cool. Right? Oh, thank you. My few sign language. So now I start looking, what's the next thing I do? Once I've freed everybody up, the whole reason I did that is so I can combine like terms. So what like terms do I have over here?
Minus 10.
I like it. So these are like terms here. And over here?
Minus.
Good. 3 minus 10 minus 7x. And this is still here, right? Cool. So that's the deal. And I understand. I talk a lot about math stamina. I haven't said that yet because we haven't hit a problem that's supposedly long. And I say that like an old grandpa saying, in my day I had to walk uphill both ways. But you get further in math, and this is not a long problem. A long problem in a higher math course is one that takes about 10 pages to do. So we start thinking, well, that's not long. Come on. This is relatively long. It's longer than any we've done so far because we're not done yet. So you need some math stamina just to keep with it. Some of you guys do something like, God, I've done enough on this problem. What's the next problem? You know, I understand that to a point. You just got to keep yourself going. So now you've hit that point. You've hit that point that I said is going to come up a lot. You just have to make a decision. Which way do you want to move things? And I haven't made it this way, but each time we've gone the same way. Which way would keep my x's positive? Yeah, if you add the 7 over, right? Because I could either subtract 6 over or I could add 7. It really doesn't matter which way you go. In the end, it's going to come out the same. So if I add 7, good, that goes away. This is still here. This is now 13x. That's gone. This is still here.
Add 10.
Beautiful, because now I got all our x's together. Oh, I got all my numbers on the other side. So that's gone.
Minus 4.
I like it. Now the answer is going to be ugly. Do I subtract 13? Why does that make no sense? Because subtraction cannot kill multiplication. And very often, you'll see me write on your homework, subtraction cannot cancel multiplication. I will write that a lot because it will happen. But this is multiplication. The only way to kill that is divide. I like it. Get an ugly answer. Do I care that much? No, because I'm done. If I had to check it, that would be ugly. All right, but we could still do it. We could attack it. We could put the 413s in there and start attacking it. That would be ugly, but we could do it. So that is the longest problem I think we've done so far. I always like to think about it as an upside down pyramid, right? You always have the problems go. There it is. Cool. Okay, not too bad yet. Any questions on that problem specifically? You good?
Just real quick.
Yeah,
Like
yeah.
that, you want to obliterate one of the x's first, right? Or does it matter whichever way you do it?
Add the X.
Say it again, sorry.
You're gonna want to get rid of one of the x's first, right? As opposed to getting rid of. Like,
Oh, I could have added 10 right there. You're right. I could have added 10 there first. It doesn't matter.
Okay.
My whole purpose here is to obliterate either on one side or just get my numbers to cancel on one side and show up on the other side. Get my x's to cancel on one side, show up on the other side. Right? In fact, some of you guys could do both of them at once. Add the 7x, but also add the 10 at the same time. That's cool too. I don't mind. As long as I see some work, you guys can certainly shorten it down. I like to say the more you understand, the less you have to do. Right? The less you understand, the more you should do for yourself so you can see all the steps. Okay, let's try another one. Here, you guys try this one. I'm not going to say anything.
Please no fraction.
Right?
Oh, come on. Now that you've said that, I'm going to have to know. If I don't do fraction in the class, you're going to have to do it on the test. You won't have any practice with it. That'll suck. I won't do that yet. Let me see. I think I want that to happen. Yes. Okay. Yeah. Oh, sorry guys. I'm trying to force something to happen. Yes, no. Sorry. Make that a plus in there, son. For those of you who are speedy, I'm sorry. Erase your first line. So make that a plus right there, okay? Where you see that? Make that a plus right there. here. What's the operation between this and this?
That becomes negative 3 plus.
So what's in front of this 3 minus x? What's in front of there?
That's a 1?
A negative 1. Understood, right? So what should you do?
Does that become negative 3 plus?
I like it. Distribute the negative.
So maybe I just put 0 x.
Oh. Okay. When it's negative x plus x, what do you call that? Is that undefined?
That's 0. The x's cancel out.
0?
So you should be getting a little bit weird of an answer. Don't worry.
Oh, okay.
I'm not doing that to totally be evil. It's in the homework. I want to be sure you understand when you get that answer what it means. I do this a lot. All right, let me try to catch up with you guys. What's the first thing you guys did? Distribute. There's a couple places to do that. Now here, that 2x is subtracting this, but what's out here is understood to be a negative 1, right? So then you better distribute that. I would say don't even think, just distribute the negative. The negative is going to change all the signs inside, right? That's all it does. Negative out in front of something means the opposite of that thing. So 7 is still here. Minus 2x is still there. Minus 3 plus x. Now you combine like terms. What do I have over here?
Minus 9.
Good.
Negative x.
I like it.
4 minus.
I like it. How have you done so far? Is that roughly what you guys got?
Yeah. Yeah.
I'm not exactly sure why I keep getting confused. So I take this, the negative 9 minus 3x plus 2x, and then I think the negative for the 3 and that is. So I got.
What'd you get? Sorry.
I just figured it out.
Oh,
I figured
okay.
out what I did wrong.
Okay, cool. That's the wait and see approach to teaching. Yeah.
0 plus 17.
Yes, exactly. Good. That's the next step. Any other questions though so far?
Oh, it's negative 15. Is it?
Oh, negative 3 times 5?
Yeah.
Negative 15. Right? Yeah, 3 times 5 is 15. Negative 3 times 5 has got to be negative 15. No other negative to cancel that out. Cool. Now, you could go one of two ways here. And a lot of people, what you do is you don't let the x go away. And it wants to. How do I kill the x here? Plus x.
But if you add to the other side, doesn't it cancel it out?
I like it. So then what do you get?
Nothing.
No, you get something.
Negative 9.
Negative 9 equals 4. Now, this is where people go, screw math. Unless if you haven't already done that.
Yeah.
But what math is saying is, you gave me bogus shit to start with. I did that on purpose. You guys saw me make a mistake. I was trying to make it do this. Because if I give it an equation that can't work, math is going to say, well, if you can do that shit, I can do this shit. Screw you. Right? It's just to be a little blunt. What math is trying to say, when I get an answer like this, who remembers? I was very specific here. What does this mean? When this is true, this is true, right? When is this true?
Never.
So when is this true?
Never.
So what's the answer? No solution. Pop. So this is all math. Math can't suddenly come in, poke its head in your door and say, no solution over there. No, the best it can do is say, well, if negative 9 equals 4, then your equation is good. So you go, oh, you're trying to tell me my equation sucks. Okay. There's no answer to this equation. Yeah.
Do you always have to do the variables first, or could you do like
No, you could, yeah, you're right. That's what I was saying earlier. There are two ways to go with this. You have to eventually add the x. But you could have added 9 maybe first. Right? And then add the x. So you get 0 equals
Oh,
13?
okay.
I can still get 13. I can add a 9 here, can't I?
Yeah.
I can still get 0 equals 13. Is that true? Thankfully, 0 is not 13. I got $13. No, you got 0 now. Because 13 equals 0. Shit. No, that's not true. So when is this true? Never. So what's the answer? No solution. Just to show you. And this is where you guys, and I, even with what I just said, some of you guys are still like, this is one reason why I hate math. If I give math a problem, let me give it a very simple problem that I know from the beginning is bogus. Is there any number that equals that number plus 1? Can you come up with a number that's the same if I add 1 to it? Some of you guys think this is a puzzle. No. If I add 1 to a number, it's 1 bigger. Is there any number that is equal to what it was plus 1? So what should math give me as an answer? A bogus answer that will tell me, oh shit, my equation sucked. You guys with me? This is why sometimes math gives us a bogus answer, because it's trying to tell me your equation can't lead to anything good. It doesn't work. Was it easy to tell here that it was going to come out bogus? No. Is it easy to tell here? Yeah, because it's not much going on. This equation says a number is the same as that number plus 1. And so what would be my first step here to actually try to do algebra? What would be my first step here to solve it? Subtract x, to get the x's together, right? What I always get is somebody who puts an x there, because you don't want to let x go. X minus x is not x. X minus x is 0 equals 1. So math is telling me exactly what it should. It's saying if 0 equals 1, you're golden. So I go, oh, 0 is never 1. It never works. No solution. Have you guys seen that kind of problem before? No? Yes, some of you guys know. But it should make sense that it's going to be out there. Because what do equations, let me say this since we're talking about equations. What do equations represent? What could they represent? Anything. So equation, one thing I always go to, of course, is, again, money. Money's not my whole life, but we all can associate with money. Money, I could have an equation that represents my profit. So I could say, here's my equation for profit, blah, 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 blah. And I will say, okay, when will my profit be $1 million? When will we make it $1 million? And I do the math, and it comes out to 2 equals 7. What is the math trying to tell me? You ain't gonna make $1 million, right? You better change some physical aspect, increase your manufacturing, lay off some people, whatever, and then maybe the equation would work, because that would change some pieces of your equation. Your equation has in it all the money you have to put out, all the money that you get in, so maybe you got to raise the prices, lay some people off, which is unfortunately what's been going on, and then maybe you get up to your $1 million threshold. You guys see the connection between what the hell, stupid math, does this weird shit, what the hell, but that has physical meaning. If I want something to happen and I do the math and it says 2 equals 7 or whatever, it's telling me it ain't going to happen. You can't do it, right? So let that happen. If the x's go away, let them go away. That's actually easy. Now on the other side of this, I could have a problem like this. What is this? What is that?
2x plus 2?
All right. Does it matter what x is? That's going to be a neat part of that video. All right, poor little dude. Forgot I had that set up. Now, is everybody cool? This is not really an equation. It's more like a definition, right? But if I look at it as an equation, the answer, should the answer be like x equals 5? That this only works for 5? The distributive property works for, what's the correct end of that sentence? Everything. So my answer should somehow mean everything works, right? You with me? A little bit? If I try to start doing algebra, what do I do?
Look at 2x plus 1.
What's your next step?
Add 2x or
Minus 2.
Minus 2x. You can do that, sure. What do you get? When is that true? Always, right? It's not false on Tuesdays. This is always true. So when is your equation true? Always. No matter what x is, this equation is true, so the answer is
True.
no. Your answer to an equation must be a number or a set of numbers. So your answer to this equation is all real numbers. What works for x? All real numbers, right? What worked here? Did any real number work here? No. No real number works here. No solution. Is there a specific number that works in this one? No, it's telling me 2 equals 2. That's when this is true. Well, that's always true. So any real number, all real numbers. That would be your answer. Don't say your answer is true. I can't plug true in for x, right? What's true plus 1? I don't know. Your answer's got to be numbers. Or in some cases, no number works, right? But it's got to be numbers, so all real numbers works. How are we doing? Yes, ma'am.
So if we have a problem on the homework that says solve for x and we end up with 2 equals 2,
The answer is all real numbers. If you end up with 0 equals 13 or something like that that's not true, no solution.
Okay.
No x can save that. Right?
Does that answer all real numbers?
That's the answer. Beautiful. Try it. Put a 5 in there. 5 plus 1 is 6 times 2 is 12. That's right. And then what's twice 5? Plus 2? 12. Of course it's going to work for all real numbers because this is the distributive property. Right? So it shouldn't matter what x is, and that's what the math came out. It said, when 2 equals 2, you're good. Am I ever not good? No, I'm always good. 2 is always equal to 2, so it's all real numbers. Unless you're an accountant. But that's another quote. That's a whole other thing. Okay. Let me try a couple more. I'm going to work with you guys, and then we'll head out. Just to warn you, the next topic we're getting into is the one you've been waiting for.
That makes glasses done.
Word problems. You should have known I was going to be sarcastic with that. Come on. I want to do a couple of fraction problems together with you, and then we'll call it a day. Okay? I sort of on purpose made this so it would be a really ugly common denominator for all three. Not really ugly, but ugly enough. So you maybe don't want to do that. You maybe want to attack this directly. And don't look at the fractions. I know that's the first thing we look at when we say, I don't want to do that problem. But I mean, just look at it as a number plus some x's equals a number. So what do you know you have to move?
2 7s.
Yeah, you want to move.
He was saying to flip the 3/4 and move it over.
You're a little ahead of me. You almost always divide last. So multiplying by a reciprocal is dividing by the coefficient. So yeah, that'll be the last thing we do, but that's right. The first thing I want to do is to get the thing with the x in it by itself, right? All my x's are together. What's not together yet? My numbers. So see, I mean, that's what I mean. The process of solving an equation does not depend on what's in the equation. Decimals, fractions, whole numbers, or whatever the hell's in there. You get x's on one side, numbers on the other side, right? Fractions are in there. I don't care. I just get my numbers together. So what do? Minus 2 7ths. So you get 3/4 x. Now what's going to be the LCD here?
21.
Beautiful. So this is already 21. And this I've got to multiply by 3. Yeah, good. So 5 over 21.
Now you flip them around, right?
21.
Say again?
Oh.
Now you multiply.
Is everybody cool with this so far? All I did was to subtracted that number over. Why did I do that? Because it's an equation, not because it's fractions. No. The fact that it's fractions will make it harder to put my numbers together, my like terms, but it doesn't change what I do, right? So here I had to get like denominators, so I multiply by 3 to get like denominators, put those together. Now what's kind of the shortcut here? When I have a coefficient that's a fraction, what can I do to kill that fraction? Multiply by its reciprocal, right? Because think about it, how do I kill the 4? What operation is right now? It's divided by 4, so I would multiply by 4. How do I kill the 3? Divide by 3. So how do I kill them both? Multiply by 4 over 3. That'll do both those things at once, right? Whatever I do to one side, gotta do the other side.
And when you're at that point, you just multiply across.
Now here, what happens?
Well, that cancels out.
Okay,
the,
I'm with you.
Yeah.
So here, anything cancel across or up and down? No, so then you just have to multiply straight. 5 times 4? 21 times 3? There you go. How do I know this won't reduce? Because its parts won't reduce. 63 is not quite prime, but at least it doesn't have anything in common with 20.
Yeah.
Cool. Okay. I told you I'd do 2 fraction problems. Here's the last one, and then we'll head out. Oh, let's not make it too easy. Here I'm just trying to make a point. There's something I could do here on the first step that I could not do here on the first step. I'm not saying you shouldn't do that. You actually multiply by 7 is a good idea. But in fact, that would be all you have to do, really. But what's another thing I could do here specifically? Because I have, how many fractions do I have on this side? 1. Something over something, right? How many fractions on this side? When I have an equation with 1 fraction equals 1 fraction, I can cross multiply. Because if I multiply by 7, doesn't it cancel here? Didn't it sort of just come up there? You see that? If I multiply by 3, doesn't it cancel here? And just kind of come up on this side? So cross multiplying is a shortcut. It says you're going to multiply and they're going to cancel and they're going to show up over there anyway. Just cross them on up there. This is the one time you're allowed to cross multiply, if you want to. It's not the only way to do this problem. You're right. There's other ways to do this problem. What do you get here? Yeah, because what happened to the 7? The 7 canceled, didn't it? 7's gone. Yeah, so 15 plus 9x, good. And here the 3 cancel. 2 times 7, 14. Exactly. So if you multiply the 3 up, 15 plus 9x, multiply the 7 up, 7 times 2 is 14. Cross multiply, that's fine. The nice thing about cross multiplying is, are there any fractions here? No, it always guarantees you no fractions because you're taking the bottom and putting it up. No bottoms, no fractions, right? So what's the next step here? I like it. Good. Good. -1/9. I like it.
Please repeat again, please.
Right.
All right. Real quick. So the shortcut here is multiply the 3 up, or cross multiply. It's a shortcut. So 3 times 5 is 15. 3 times 3 is 9. Cool. Multiply the 3 up to that side. Multiply the 7 up to the other side. 7 times 2 is 14. And now it's a nice, straight problem. And the one thing I forgot to say is, once you've done this step and you're here, cover that. Sometimes I tell people, take another sheet of paper and cover it. I don't care what this was. This is where I am now. Don't think, oh, it was a hard problem. It ain't a hard problem anymore, right? All I gotta do now is move that number over and then divide by 9. Cool. Okay. All right, guys, so you desperately have to get chapter 1 looked at, so you're ready with any good questions from what I'm assuming you kind of know. So come ready for that Monday. Yeah. It's on the homework sheet. I think it's 13. I think that might be a Friday, so it might be. No, it's not a Friday. No. Yeah. Oh, and the answer. Okay. So the reason I do that is so that you do have some that have the answer, and I make sure that the way I assign homework, you have odd problems that are just like you need to prove. What's going to happen on a test that you need to get practice for is to not have to say to not know for sure. So you do have odd problems. You can know with the answer. Oh yeah, chapter 1. Because the test and the review, all the answers are in the back. Yeah. Yes. Yeah. The tests and reviews. Let me make sure I know what I'm talking about. Pretty sure the tests and the reviews. Yes. Yes, the tests and the reviews for any chapter, all the answers are in the back. Just the homework sections themselves, they don't have all the answers, they only have the answers. Oh, the Wolfram Mountain. There are websites where you can plug in math problems, and it'll show you how to work it out.
Doesn't surprise me.
I do. I'm gonna try to make sure you don't. But a lot of times it's easy for me to tell if somebody knows, because the way it does some problems is harder than you should know. They're not bad to study. They're not bad to study. You know, if you know, it's hard for me to tell the honest students and the students who are looking for an easy way out. If I knew all my students are honest, I could be very honest about, here's the website, go there and just double check your homework. But some people are going to go there and just copy. It actually ends up being 5%. Exactly. But I need you to understand, not everybody realizes that. They all see it as, I have to get an A on my homework, because they know I'm going to suck on the test. So I'm cheating on my homework. And that's why they suck on the tests, because they don't do the actual work. So many people don't realize I gotta kind of trick them into doing the homework sometimes. That's why I give it some. I wish I didn't have to assign any percentage to homework. That would be perfect. But I have to give it something to get people do it. Not too much, because then people will overachieve and say, "Whoa, homework's 20% of my grade. If I cheat and get an A, it's fine." So I make it about 5%.
But that's just me.
In the end, because factoring them with the quizzes.
What? Lori.
I have issues with the negative, the energy stuff because of the fact I haven't done math in 5 years.
Most of them got A's?
So I was wondering if there's like a website you can do, because I don't have a book right now, to practice.
There's a really cool. I should put the link. If I think about it, I'm gonna put the link.
And I'm sure she passed
I can't remember if
too, which
it's
was
org or
like
com.
ridiculously hard.
The sound's kind of weird. Khan Academy.
Oh man.
I don't know if you guys have ever heard of it. But this guy, it's crazy. He's really good. I've looked at several of the videos, and he's got all different levels of math and different chemistry and stuff. All these different videos for all these different topics. So he's taken algebra and broken it down into topics.
So I'm retaking this one
And
to get an A for
so you can go there and see videos.
Because if you get a
Of course, I'll be posting my videos too.
Yeah, I get the videos, but I know it's just integers. It's just